We're going to start with a property of matter that's responsible for everything we talk about in this entire class. Everything that we talk about is due to charge. So I like to give simple definitions, simple plain-spoken definitions of things. So my simple definition of charge is that it is a property of matter that creates force. For now, that's all you need to know about charge. It is something that matter has, or maybe doesn't have, that creates force. Now, when we think about charge in physics, when we first start to learn about charge, it gets a little confusing because we jump around between small things that have charge, microscopic things at the atomic and molecular scale, and large things that have charge. And we have different units and different amounts. It gets a little confusing. So I like to go through each one very carefully so that we can think about the link between them. So let's start with micro charge. So I'm going to draw a diagram that you may be somewhat familiar with. So we have a bunch of little p particles and n particles and flying around out here. We have these like that. So you've probably seen this diagram before. This is, of course, an atom. We could even think about which atom it is. This is lithium. Lithium's a very cool element. It's used to make nuclear weapons and grease, and it makes you feel better. And Nirvana wrote a song about it. So that's the 4 things I know about lithium. That's pretty much it. So this is not a chemistry class. So let's think about what's in this atom. It has protons, neutrons, and electrons. Let's look at them one at a time. The proton, particle sitting here in the nucleus labeled P. Let's see, what charge do they have? The charge of a proton is plus 1 e, where e is the unit of charge. E is called the elementary charge unit. All right. Let's look at another particle inside of here, the neutron. Neutron, also in the nucleus, it has a charge of 0 e. It's neutral. It has no charge at all. And then finally, we know these little guys flying around the nucleus are the electrons. And they have a charge of minus 1 e, minus 1 elementary charge unit. So one important thing, even at this early stage, is to keep in mind that e is just a unit. It doesn't mean electron. It's not inherently negative. It's not the charge of an electron. It is the elementary charge unit. It's not negative or positive. You know, units don't have a sign. Units are just units. You have to put something in front of it to have a sign. Okay, so E, sometimes we write a little E and mean an electron. Sometimes we even put a little dash on it. That's the negative sign. But when we're talking about a unit, E is not positive or negative. It's just a unit. So plus 1 E for the proton, minus 1 E for the electron. If we want to start thinking about comparing this to macroscopic charge, there's another unit, and it is the coulomb. So 1 E of charge is 1.6 times 10 to the minus 19 C, where C is coulomb for the macroscopic charge. And the neutron, of course, no matter what the unit is, 0 is 0. So it has a charge of 0 coulombs. And the electron, it's the same but negative, so minus 1.6 times 10 to the minus 19 coulombs. So here you can see that the difference between micro and macro is pretty big. Coulomb is a macroscopic amount of charge. An E is a microscopic amount, and the difference is 19 orders of magnitude. That's quite a bit. We could also think about the mass of these things. So the mass of the electron, we'll start giving it in U, is 1.007 U, where U is the unified mass, or unified atomic mass unit. The neutron is very similar, 1.009 U. Okay. And then what you may know about atoms is all the masses in the nucleus, these little electrons flying around, are very low in mass, and they have 0.0005 U of mass. If you're a chemist and you're wondering that looks similar to a Dalton, those are Daltons. In physics, we call it U. unified atomic mass unit. In chemistry, it's the same as a Dalton, carbon 12, it weighs 12U, all right? We can also, just to keep comparing to macroscopic, we can put this in kilograms, 1.7 times 10 to the minus 27 kilograms. So that is a really, really small mass, all right? Atoms don't weigh much. Another thing you'll notice is when we're just being sort of approximate, when we're keeping up with things to about this level, 1%, say, then you can see that the proton and the neutron are very close. So if we're just keeping two figures, then this would also be 1.7 times 10 to the minus 27 kilograms. Okay? And then finally, if we're really keeping this level of precision, the electron is essentially massless, right? The electron is very light. We could also say it is essentially 0 times 10 to the minus 27 kilograms. It's not really 0. It really has some mass. But if we're just sort of being approximate about where all the mass is, it's really all in the nucleus, and the electrons are essentially massless flying around the outside. So that's where the charge exists on the microscopic scale. Now let's see how we can charge something up.